StoneL was founded in 1989 to serve the process industries by working with valve automation suppliers to offer the best-in-class valve monitors, or limit switches, as they were called at the time. Our products have changed, with our focus now on valve communication solutions, or as we like to say, enabling valves to think and communicate. During the 90s, StoneL grew rapidly by expanding our product line to include integrated solenoid valve control. We also created our own solid-state proximity switches and sensor modules. Our communication networking products were launched in '98, along with our communication-capable valve monitors, which we call Valve Communication Terminals, or VCTs. As a result of these initiatives, we won the Techni Award that recognizes the best companies in the state of Minnesota for using technology in a way that offers exceptional savings for customers. Our horizons expanded in 2000 when we were acquired by Metso and tasked to further build our valve automation channels as well as support the Metso Flow Controls organization. We've been able to do that by more than quadrupling our revenues, building our sales organization worldwide, and expanding our technology, development, and manufacturing capabilities. Our values focus continues to be to contribute to our customers' success, and we do that every day by taking personal ownership of our processes, products, and services. We have found a good start to that process is to have sales managers located in the field, close to our users and channel partners, and support them with a well-qualified technical support team. We want to understand what our customers would like to have if they knew it was possible to create. That's the exciting focus of our technology and product development team. Our staff of mechanical designers and electronic firmware and hardware engineers has an extensive array of tools to bring those problem-solving ideas into exciting new products. By using state-of-the-art electronic and mechanical design software, rapid electronic board prototyping, and our own in-house 3D modeling systems, our team is able to quickly translate exciting concepts into functioning prototypes. In the early stages of development, these prototypes may be used for operational and function testing as well as field reviews with our channels and customers who will ultimately install and use the products. After our development group has created hard tooling for new products, our reliability engineering team has an opportunity to run through our extensive Crucible testing process. This series of tests simulates worst-case field operating conditions, condensing 10 years into approximately 4 to 6 months. This is quite a challenge, so we do both in-house and external tests. Some of those include shock and vibration tests with varying temperature levels, life cycle tests, temperature extremes with varying humidity levels, and thermal shock tests. Other tests include ultraviolet exposure, mechanical impact tests, steam cleaning and high pressure, up to 7,000 psi, jet spray tests. On top of that, we perform corrosion resistance testing using a number of different solvents, acids, and caustic solutions. There is also a full battery of electronic, functional, and communication protocol compatibility tests where we typically use our own PLC and DCS systems, similar to those used in actual plant operations. In addition, we verify CE compliance with electromagnetic immunity, electrostatic, and electromagnetic emissions tests. Following our own testing, our quality and engineering systems team submits products to third-party testing agencies for hazard compliance to North American and international standards, as well as numerous other specific country nationally recognized test labs. StoneL currently works with over 12 different labs worldwide to assure full compliance to intrinsically safe, non-incentive, and explosion-proof hazardous area protection concepts, as well as IP and NEMA enclosure ratings. Our manufacturing process has 3 main areas consisting of electronic assembly, metal fabrication, and final assembly. We focus on Lean and Six Sigma techniques throughout our production and product creation processes. The first step in the manufacturing process actually begins with designs that minimize connection points and modularize our electronic circuits. Many of our customers are familiar with our dual module and C modules, which feature simple, easy-to-use electronics that are completely sealed in a moisture-proof system for the ultimate in reliability, convenience, and space efficiency. We begin the electronic assembly process by stress testing all populated electronic printed circuit boards. Following that, we do a microscopic review to evaluate all solder joints and part adhesion. Following successful completion of the thermal cycling process, final soldering is performed in a humidity and electrostatically controlled assembly area. Depending on the complexity and volume, circuit boards may be either hand or robotically soldered. Once the circuit boards are completed, they are conformally coated and inserted into specific module cases in preparation for final potting. The modules are then potted using a special material designed to comply with hazardous requirements and well suited for thermal stresses, corrosion resistance, and moisture protection. One of the key capabilities we offer is the ability to quickly and securely adapt all of our platforms to the myriad of quarter-turn and linear valves in the market. Our service includes design and fabrication, which is ongoing. On top of nearly 2,200 unique mounting kit designs, which are manufactured in stainless steel, we cover over 18,000 applications. Each day, electronic modules, machined and finished epoxy-coated enclosures, and other component parts are coordinated and kitted per individual customer orders for assembly. Labels and serial codes with specific models are created by the kitting specialists so each product may be traced to the exact date and batch of parts used for that specific run of products. Final checkout and tests are performed after assembly to assure full functionality prior to shipping. Key suppliers have personal visits on a regular basis to discuss any product changes, improve on cost and delivery performance, and discuss how to jointly create improved results. The manufacturing team schedules each item for final assembly, which seamlessly coordinates our parts supply with existing order backlog and planned orders. So we also integrate vital project data from our CRM system to anticipate what parts will be needed. For smaller orders, special attention is given to our Rapid Response Program, which offers 24-hour shipment for a number of standard premium value products. Our objective for this program is nothing short of 100% on-time delivery. Backing up these programs is our Operations Support Group, which consists of order entry and logistics, who focus on being nimble and efficient with an emphasis on responding to special, expediting requirements. They have extensive experience working with global customers and shipping requirements.